This is Devak Shah from LT Institute of Engineering and Technology under the LT University. So far today we are going to learn about the different digital codes which we are going to use to build a digital logic design or digital systems. During our previous session we have discussed about the different numbering systems. Followed by this numbering systems, now we design a kind of specific type of codes. Normally these codes are defined as the binary code, right? So if we first start with a binary code which we define as a binary coded decimal. This code is defined as a BCD code. So if we define that particular code, we represent like the digital code. It is the process of using binary digits to represent letters, characters and other symbols in a digital format. Now why this is very important statement? Because the digital system or a computer system, they can understand only and only the binary system. So here we can represent any alphabet, any numbers in form of binary numbers. Now there are certain specific applications of those kind of binary codes because we have to encode and decode the information. We have to display the digits on a screen, on a display box, as well as we have to encrypt and decrypt the information that we are particularly using for communication systems like satellite communication system, mobile communication systems, and so on, right? So we further discuss about the several types of digital codes widely used in today, but they are the same principle of combining binary numbers to represent a character, right? So you might have seen this kind of 1 and 1 0 strings, right? Or train pulses that nothing but represents a specific information that includes a kind of alphabets and numbers. So if we learn about the specific type of those digital codes, today we are going to discuss about the BCD, which is called a binary coded decimal code. Then we have a ASCII code that you already know about it. Then is EBCDIC code, right? But in our today's session we are going to discuss about the BCD code, gray code and access code. These three codes we are going to use as a accordance with the numbering system that we can convert BCD number into gray code either in access key. Same way we can also going to convert, or we can also convert a decimal number into binary number, octal number, hexadecimal number, BCD number, access 3 number, or BCD code or access 3 code, as well as the gray code, right? So we further discuss about the BCD is nothing but the binary coded decimal number, the storage of numbers in which the decimal digit is converted into a binary number which is represented by 4 bits. So one digit here in a BCD you can represent by 4 bits. So further discussion that BCD uses the more storage for numbers in a binary encoding. We are using this BCD number as a encoding and decoding purpose. So for this particular BCD is a kind of packet decimal number which is available in form of digit 0 to 9 and converted a corresponding digit into a 4 bits, right? So here what are the different advantages of BCD code? What are the different advantages of BCD codes here? So it is easy to encode and decode decimal in BCD and vice versa. It is simple to implement a hardware algorithm for BCD converter. It is very much useful in a digital system wherever the digital information is either as input and display as the output. So normally we can use for a display purpose. So in digital voltmeters, frequency converters, digital clock, all digital gadgets, we use BCD as a display output information in decimal, right? So wherever you require a kind of display, and if you want to display any number, any alphabet, you can use this BCD number. So normally we can display the numbers, right? So how you can convert 0 to 9 decimal numbers both in a binary as well as BCD, right? That is represented in this table. You can see the binary code ABCD and that corresponds to the decimal number 0, and further it is converted into a BCD code, right? So you can see here from 0 to 9, see it looks that binary and BCD both are same. So for 0 to 9 decimal numbers, from 0 to 9 decimal numbers, binary and BCD both are having the same pattern. So from 0 0 0 0 to 1 0 0 1, right? But as long as once you shift from 9 to 10, see, from 9 to 10, one digit is converted into a two digits. So in binary, 10 is represented as a 1010 and BCD is represented as a 1 and 0000, right? Why? Because each digit is represented in form of 4 bits of binary. So here you can see the differentiate of the bits or of the code from binary to BCD. So from 9 to 10 decimal number or digits, you can see the difference, right? So up to 15, you can realize the difference. 15 is represented in a binary as a 1010 form, but in a BCD is 1 and 5 is represented as 0101, right? So now this is what a kind of BCD representation. So now this is what a kind of BCD representation where you can convert BCD number from decimal number to binary to BCD like that way, right? Now the next important code we define as a access 3 code. Now what is this access 3 code? That is a specific abbreviated form of access 3 is a non-weighted code used to express code used in an express decimal number. So some of the decimal numbers we can express in terms of the access 3 code. So it is a self-complementary binary coded decimal BCD code and numerical system as a based representation. So this is one more representation of a decimal system like BCD. So it is particularly significant for arithmetic operations as it overcomes the shortcomings encountered while using the 8421 BCD code. While 8421 is nothing but the kind of sequence of the BCD code. Once you write like 8421, it's nothing but 2 raised to 0, 2 raised to 2, 2 raised to 3, 2 raised to 4 from LSB to MSB. So 8421 is the sequence for a BCD, and here you have to add plus 3 in this particular sequence like 0011. You have to each time or with each digit if you add, it must be converted into BCD to access 3, right? So here the access 3 arithmetic uses different algorithms than a normal non-biased BCD or binary position number systems, right? So there is a specific purpose we are using this access 3 code, like how you can represent this access 3, which is again are unweighted and can be obtained by adding 3 to each digit, decimal digit. Then it can be represented using the 4 bits of binary of each digit. So for that you can just find the decimal number of any given binary number, and here you have to add plus 3 in any decimal digit. Once you add plus 3 in a binary form, you have to add 0011 in a BCD number. You consider any decimal number as a digit, and then for each digit you have to add plus 3. In binary form you have to add 0011, right? So based on that, if we further discuss about the access 3, you can see the conversion table from decimal number to BCD number to access 3. You can see here from a decimal number 0 in a BCD form you represent it as a 0000, right? But in access 3 you have to add plus 3. So in binary form you have to add 0011. So in BCD code 0000 you have to add 0011. So you have to add plus 3 of corresponding or individual digits, right? So 0 plus 3, decimal number is 0, and the binary representation of that decimal number is 0011, right? So you can convert here decimal number into a BCD number into a access 3, right? So always in a decimal number or decimal digit you have to add plus 3, and then whatever number you are going to get you have to convert into a binary form, right? So you can see from 0 to 9, 9 in a BCD number is represented as 1001, right? But you have to add plus 0011, say it becomes 1100, right? So this is what the representation or conversion from decimal to BCD to access 3. You can directly convert decimal number to access 3 as well, right? So this two codes 0000 and 1111 are not used for any digit. So just you see one of the example is called convert this decimal number 23 into access 3, right? So here you have to convert 2 3 in form of BCD, or you have to consider this 2, 3 as part of the digit. So 2 is the digit, 3 is the individual digit. You have to add plus 3 in this individual digit, like 2 plus 3 and 3 plus 3 from LSD to MSD, right? From least significant digit to most significant digit. So you have to add individual digits plus 3 and plus 3, and the answer is 56. And then this 56 you have to convert into an individual digit. 56 you have to convert into a binary form, right? So once you add plus 3, anyway it becomes the excess 3. So there is a conversion of decimal number into excess 3, right? So here the answer is 56. So 0, 1, 0, 1 and 0, 1, 1, 0, right? So how you can convert this decimal number into excess 3? You can see from example number 1. You can also go through the example number 2 and convert this decimal number 15.46 into excess 3, right? Again, for each digit you have to add plus 3. So 1 plus 3, 4, 5 plus 3, 8. So 4, 8 dot, 4 plus 3, 7 and 6 plus 3, 9. So that complete number you can define as 48.79, and that individual digit here you have to consider. So 4 is again represented in form of a binary is 0100. That's how you can convert into a excess 3, right? So you can see the series of excess 3 from 15.46 individual digit you have to add plus 3 and convert that obtained digit into a binary form. You can have excess 3 code, right? So based on that example, now you can be able to convert decimal number into a excess 3 code. Now again, encode the decimal number 2, 3, 4, 5 into a BCD as well as excess 3. Now this the very the complete elaboration of those digits are given. So you have to make it like individual 2, 3, 4, 5. You can convert into a BCD, that is nothing but the 4-bit representation of binary of each digit. It is a BCD, and again you have to add plus 3 to make it the excess 3, right? So you can see the complete excess 3 code of 2, 3, 4, 5, right? So you can go through that particular example and you can make your own calculation and you can go through this, right? So this is how you can convert any decimal number into excess 3 code, right? So check this one. Again, there are more examples as given in form of the vice versa process, the reverse process, that we can convert excess 3 code 1001 001 into a BCD, a decimal number, right? So far what we did, we have converted decimal number into a BCD number as well as the excess 3. Now excess 3 number you have to convert into a BCD and a decimal number. So again the rule is same. Excess 3 is nothing but the already added by plus 3. So now you have to subtract 3 from individual digits. So now 1001 and 001. So now you make it this 7 bits into a 8 bits, like from start from LSB to MSB, and you make it 1001. So that number is called 9, and 0100, that number is 4. So 4 and 9, that individually you have to subtract minus 3 from 4 as well as from 9, right? So once you do this, so you can see this particular sequence is like 0100 minus 0011 as well as 1001 minus 0011. Once you do this, you'll be able to find answer is 1 and 6. So 0001 and 0110, right? This is in form of the binary, and you can convert this binary form into a decimal by just putting the digit, or convert this binary form into a decimal number. Now what are the different advantages of excess 3? So these numbers are unweighted binary decimal numbers, because you have to just simply add plus 3. These are self-complementary codes, so you can use those kind of codes for further communication systems. This use the biased representation, and these codes are 0000 and 111 are normally we are not using for any digit. So it has no limitation. It is considered simplifies arithmetic operations. So we are using this excess 3 for the arithmetic operations. So it is particularly significant for arithmetic operations. It overcomes the shortcomings encountered using the 8421. So normally in any arithmetic operation like addition, subtraction, multiplication, division, you can use this access 3 directly by adding just plus 3, and you can overcome the confusion. Right now, again, this particular code we define as the gray code, and that again you have to convert this decimal number into a gray code. Now, what is this gray code? So the gray code is nothing but the sequence of binary numbers, which is also known as a refracted binary number. Now, this is a specific kind of code, and that code we are using for a specific purpose, for a kind of the generation and a checking of the data. For those purpose we are using those kind of gray code. Now, what is the speciality of gray code? You can see this. The reason for calling this code is a refracted binary code is nothing but the first n by 2 values compared with the last n by 2 in a reverse order. So how you can understand this? By making the two consecutive values are different in a 1 bit by the binary digit. That means if you have a sequence of some of the binary bits, let's say 0 0 0, the next one is 0 0 1. That means there is only a change of 1 bit once the data is moving from one state to another state, right? And my next would be 0 1 1, not like 0 1 0, because there is no change of the 2 bits at the same time. So gray code is nothing but the once the state is moving from one to another, only there is a single change of bit that is represented by the gray code, right? So these numbers are caused the ambiguous errors when the transition from one number to successive is done. But this code simplifies the solve the problem of changing only one bit at a transition is between the two numbers, right? So if you consider this particular code, it's like a cyclic variable code where you can use this particular code for the transition from one value to its successive values carries the change of one bit only, right? So you can see different advantages of gray code. Like gray code, if we go through one decimal number to next, only one bit of gray code is changed. That is what is required. Because of this feature, the amount of switching is minimized and reliability of the switching system is improved, right? Advantage of gray code over binary is only one bit changes for the each step, right? So how you can generate the gray code? You can observe this. Normally n is equal to 3, and then you can observe like first binary bit is 0 0 0, then the next one is 0 0 1, the next one is 0 1 1, and the next one is 0 1 0, right? So you can see here there is only a change of 0 to 1, right? 1 is remains constant, that's a 0 to 1, and 1 1, so see 1 is being constant and 1 to 0. So each stage from first stage to second stage to third stage to fourth stage, likewise up to seventh stage, you can see there is only a single bit change in a binary sequence, right? That's what the importance of the gray code, right? So you can further see the conversion of decimal number to a binary number and binary number to gray code. You can straight away observe the binary sequence like 0 and 1 from 0 to 10. Check 4 binary numbers of each stage from 0 to 1, 1 to 2, 2 to 3, and likewise up to 10. You can have the difference of binary numbers and a gray code. In gray code, from the stage is moving from 0 to 1, 1 to 2, and till 10, you can observe only a single bit change in a gray code, right? So this is what the importance of the gray code. Some of the important example we can see here: convert this particular binary number into BCD. Now we already know this particular binary we can convert into a BCD form. How you can convert into BCD form is nothing but this binary number you can convert into a decimal, and each decimal digit you have to convert it into a BCD form. So this is what stage 1. Again, the stage 2, how you can convert this 29 number into the BCD. Individual digits you have to represent in the form of the 4 bits of binary. So 2 is 0010 and 9 is 1001 that you can convert into BCD. So there are some of the examples. Again, you can see convert this particular BCD number into binary. So BCD number is itself a kind of digit. So 29 decimal number, again you have to convert into a binary by using the method, right? So you can see all those different kinds of conversions are available. Like this BCD number you have to convert into XS3. So individually you have to add plus 3, and then you can convert into a BCD form or binary form. So here again you can convert this particular XS3 into a BCD. You already know the rule. How XS3? That means you have to subtract -3 from the digits, and then you have to convert into a decimal number or BCD number, right? Thank you very much. This is what the different kind of codes that normally we are using for a communication system, and how you can represent this kind of specific codes here, and the conversion of each code in between, right? Thank you, dear students. If you have any query, please write in the comment box. Thank you.